a lot easier actually than just basic probability even. Because in basic probability, since there's nothing new to learn, the questions can get harder. Since this is new, the questions are fairly straightforward. All right. So what we're going to be looking at are random variables, how they work and what they mean, how to find expected value, which is mean, how to find measures of spread, variance and standard deviation, and then sampling. And I think that's extension 1 sampling. Anyway, that's not for you guys. But just those three, 1, 2, 3. Pretty straightforward. I'm going to pass through all this, get through this. Okay, the first thing you need to know is that, I mean, it won't be tested, but you've got something that's called a discrete random variable. Can only take a discrete set of values, whereas a continuous random variable, you can only take a continuous range of values. So what we're trying to say is discrete can be only whole numbers only. Whereas these ones here are often associated with anything else. So usually decimal values or fractions. Anything else. But anyways, so discrete random variables would be how many cars you have, how many cars, how many tails when you flip a coin, so on. You can't really get 2.5. Whereas this would be what's your height, your weight. You can say 30.2 kilograms or whatever it is. Okay, I think that's nothing too fancy. Continuous random variables, that's year 12. Discrete random variables, that's year 11. So you'll be continuing this in year 12. Some basic stuff just to see if you know what discrete and continuous is. I'll let you do that at your own time. It's not interesting for our purpose. All right, the probability that a random variable x takes on the value xi is pi. Now that sounds pretty fancy, but this is how you start seeing it. Probability of x equal to little x is equal to a probability of I, or xi. So it's just trying to say the probability of an event occurring is some sort of probability. Like I said, don't let that confuse you. Don't stress. You'll see what it is in a second. The collection of values and the probabilities together is referred to as this, they're the summation of your probabilities. They will equal to 1. The probabilities p must always be between 0 and 1. And the sum of the probabilities over the whole population must be equal to 1. So what you want to take out of this is the way we're going to start writing a few things. We're going to look at something like this. You need to know that each probability must lie between 0 and 1, and that the sum of all the probabilities must equal to 1. That just makes common sense, I think. Like I said, let's look at an example because that will make a lot more sense. 4 coins are thrown and the number of heads are recorded. The number of heads is denoted by x. So 4 coins are thrown and the number of heads are recorded. The number of heads are denoted by x. So you can see you've got to complete the probability distribution table. So it's pretty much a table of values. And the way that works is you start off with x being 0 heads, 1 head, 2 heads, 3 heads, 4 heads. Any questions at this stage? Because you're trying to work out the number of heads. Any questions? No,
not so far.
That table makes sense. Good. Then we're always going to have probability. So usually you used to have y. You don't have y. You've got probability that x equals to x, which means the probability that x equals to like 0 or 1 or 2 or 3. And what we've got to first do is, I guess, work out this experiment. 4 coins. There it is. You could have had head or a tail, so not a head. And then if first coin, second coin could have been head or a tail, and so on. I think you guys get the idea. So you could have had head, 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 head. You could have had head, 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 tail. You could have had head, tail, head. All right, I'm just going to stop talking for a second and write all of this down. And then the same thing here. All right, so you would have done something like that. Maybe you would have just listed it out yourself without drawing this big tree diagram. It's up to you. Now, what's the probability of getting 0 heads? So 0 heads would be obviously 1 out of 16. Getting one head is 1, 2, 3, 4. 4 out of 16. 2 heads. 1, 2, 3, 4, 5, 6. 6 out of 16. 3 heads. 1, 2, 3, 4. That should be it. 4 out of 16. And then 4 heads, obviously 1 out of 16. All right, any questions at this stage? You understand how to complete this table? Because that's going to be definitely in your exam.
Yeah, that's so far.
Beautiful. And then like the 2 conditions. Always remember these 2 conditions. They're going to help. The probabilities must be between 0 and 1. And number 2, the sum of the probabilities must equal to 1. Let's see. Each one in here looks like they're between 0 and 1. So tick. And let's just double check it. What's 1 plus 4 plus 6 plus 4 plus 1? That's 10, 14, 15, 16. Adds up to 16 out of 16. Gives me a whole probability of 1. So the sum of all these must equal to 1. Has to. Cool? All right. So once you've done that, that's usually worth about 3 marks if it's like this, because, you know, it's long and whatever. So 3 marks. And then B, I. All right. The way we read this, probability that X is equal to 3. Anyone think they know the answer for that? Just if I was to say this, probability that X equals to 3.
Is it xi equals 3?
Yeah, technically. You don't need to see. That's what I mean. Like this is, you know, this is like, how can I say it? This is very theoretical. So don't let this confuse you. But yes, xi is 3. But then it's just trying to say like this is what I have to write, you know, because it's theory. But you don't really need it. Yes, keep going. Xi is 3, Tiana, and then what would you say? So we want the probability such that the number of heads, because X is the number of heads, is equal to 3. What's the answer?
Was this from last week?
No, just here on this table.
Okay.
The probability where the number of heads must equal to 3. The number of heads must equal to 3. 4 over 16. 4 over 16. Do you get that?
Yeah, that makes sense now. I don't know why I got confused about that.
Yeah, no. That's very simple. It's just literally that. What if I said, what's the probability that X is equal to 0? You know, all you would say is, what's the probability that the number of heads is 0? 0 heads. All right, double I. Let's see who can say this one. What's the probability that the number of heads are greater than 2? Who thinks they know the answer?
Is it 8?
8. How did you get 8?
Everything that has 2 or more H's.
Oh, you said, why did you say 2 or more? Isn't it just greater than 2?
Oh, yes, that's right, yeah.
So then how many now?
So then it would be 1, 2,
Wait, what are you
like,
reading? What are you counting?
like how many,
Isn't
like,
it isn't it 3 heads and 4 heads?
yeah,
So then I think you said the answer, but I don't know why you were counting. It's just 4 plus 1.
yeah, 5,
You,
yeah.
do you agree with that?
Yeah, but I wasn't looking at the table, I was looking at the dot.
Oh, this bit
Yeah.
here.
I was
Now you
counting,
want to look at the table because you're not really going to have this all every time. Like
yeah.
this, I mean, it's good. It's good. Let's just say it's good, but it's not great.
Hmm.
Like, seriously, you're not going to fill this out all the time. Once you've got your table, the idea is you just have to look at it. What's the probability such that your x is greater than 2? Well, that means 3 and 4. So that's probability of 3 plus probability of 4, in other words. Or I mean, see, you can't technically write this because you're doing distributions. It's this equals to 3. It's annoying like that. There you go. X equals 3 plus 4. And then that equals to 4 plus 1 out of 16. 5 out of 16. Girls, make sense?
Yeah.
And then
Yeah.
triple line. I told you this one here probably easier than last week. Probability that X is odd. What's the probability that the number of heads are odd? That means you need to get 1 and 3. Oh, I've got to get used to this, don't I? And then that becomes 4 and 4, 8 on 16, which equals to a half. Any questions? Nope. And then we do it again. The number of pets owned, the number of pets is X. Cool. Owned by each student in a large school is a random variable with the following discrete probability distribution, which is right here. If two students are selected at random, the probability that they own the same number of pets is, okay, if they own the same number of pets, that means they both could own 0 and 0, or they could own 1 and 1, or I think you guys get the idea. We agree with that? So they're two students, both have to own the same. So what's the probability that it would have been 0 and 0? Wasn't that just 0.5 times 0.5? So 0.5 squared. Or means plus, that's what we learned last week. They both have to have 1 and 1. Or 2 and 2. Or 3 and 3. Do we understand the logic of that? Of what I've just done there? Yes or no? No?
Yes. Yes.
Yes. Okay, sorry. Yep. So you can think of it again. If you have to, you would say Sam and Eden. The probability that Sam has 0 pets would be 0.5. That means Eden must have 0.5 as well, because she's got to have 0 pets. So then 0.5 times 0.5. Or Sam could have had 1 pet, which means Eden must have 1 pet. So 0.25 times 0, and so on and so on and so on until you exhaust all the cases. And apparently the answer is C. If you plug that into your calculator, it should give you C. All good?
Yeah.
Done. Let's move on. All right. Show that this function, right, p of x equals x squared plus 1 on 34 is a valid probability distribution function. Okay, how would you know if this is allowed to be your probability function? What were the two conditions? What were the two conditions for probabilities? Each probability must be between 0 and 1 and
The entire total has to equal to 1.
Which is logical, right? So each probability must be between 0 and 1 and equal to 0 and 1, of course. And sum of probability can equal to 1. Must equal to 1. All right, so if this works, if this function, I guess, if we're allowed to use this function to model this probability, then these two conditions must hold true. So let's check. If I sub in 1, so P of 1, see how I'm just trying to, you can almost say I'm doing functions here. And that's what will happen even more in Year 12. In Year 12, a lot of things will overlap, and you'll find Year 12 topics a lot easier than your Year 11 topics. But anyways, 1. 1 squared is 1. 1 plus 1 is 2. 2 on 34. 2. 2 squared is 4. 4 plus 1 is 5. 5 on 34. 3. 3 squared is 9. 9 plus 1 is 10. 10 on 34. 4. 4 squared, 16, 17 on 34. All right, can you see each one of these are between 0 and 1? So tick. And all we've got to check is, do the sum of all these equal to 1? Well, let's check. 17, 27, 28, 29, 30, 31, 32, 33, 34. Tick. Show that it is a valid. We just did. I mean, you would have to say it. You would say each one lies between 0 and 1, and then 2 plus 5 plus 10 plus 17 over 34 equals to 1. So therefore, it is a valid probability density distribution, function. PDF. All good?
Yes.
Yes. Seriously, right? It's not bad. You would say it's easier than last week, because this topic is more algebraic. So for students who like algebra, this topic works really well. All right, uniform. Uniform just means constant. So constant distribution, which is like a dice. So a die is thrown right at the probability distribution for the number shown on the die. For the number shown on the die. For the number shown on the die. So that means this will be number 1 shown, number 2 shown, number 3 shown. Good. And what's the probability of each one occurring?
1 in 6.
And can you see each one lies between 0 and 1, and that the sum of all of these are equal to 1, so it works. And then graph it. Graph at 1, 2, 3, 4, 5, 6. They're all 1 on 6. So 1 on 6, 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 1 on 6. It's not a line through it. Why is it not a line through it? Anyone tell me why that would not be a line through it?
Because it's the x-axis.
Because it's the x-axis.
Wait, wait, never mind.
I'm trying to say, why
down.
did I, that's okay, well, I'm trying to, like, why are these dots, let's say, and I'm not connecting the dots?
Because you only connect them if there is a trend in the graph.
Ooh, I like that. Okay, I'll accept that. Look, I'll accept that because I think I understand what you're saying. But look, with this one here, you can't get, for x, you can't get any numbers between 1 and 2. Right, so if you're going to draw that, yes, it's still 1 over 6, but can you even get these numbers? So in Year 12, when they are continuous, yes, you would draw a line through them, right? But in Year 11, there won't be really lines because, like, if it's a dice, you can only get 1, and that's it. You can't get 1.1 or 1.2 or 1.3 or 1.4 or anything else.
Oh, okay.
All right, cool. All right, done. That's that one. And you're done with section 1. Now section 2, expected value. Expected value is another way of saying mean. You guys know mean as average. Obviously that's incorrect. That's just taught to you in Year 9 and Year 10. It's not exactly correct. And that's something you'll learn as you get older and older. Everything you've been taught is not exactly correct. There's more and more to learn. Forever you're learning. Think of it like that. But anyways, Mean, it is kind of like average, but it is not average. So be careful. Your mean is what we say is the expected value. That's the actual definition of mean. It describes where the distribution is, I guess, close to the middle. Close to the middle. This variance describes how, I guess, how spread from the mean the distribution is, and then standard deviation, it is just the square root of the variance. So mean, we're going to work it out in a second. Variance also is just a spread from the mean. Standard deviation, we can't work that out. The way it's going to be done is going to be done through square roots of variance. So we're just going to square root this guy. Mean is represented by the letter mu, 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 or by E of x, expected value of x. Variance is usually represented by sigma squared, or sometimes you might write var x. Standard deviation, because it's the square root of variance, it's usually just represented by sigma. All right, again, terminology, great. There's the formula for the expected value of x. Expected value of x, which equals to mu, is equal to sigma, which means, and this sigma is different to this sigma, but anyways, this one here means sum of. So sum of your x multiplied by your probability of your x. Think of it like that. X times probability of your x, starting from the first one until the end. Starting at first to last. You'll understand. I'm trying to really cut off the things that look weird, let's just say. So you understand it's simply like any normal mathematician who will just say it's just the sum of the two things multiplied together. So here we go. The x multiplied by the probability of that event occurring. All right, consider the experiment. I think we had this as 1 on 16, 4 on 16, 6 on 16, I think it was. I can check it real quick. If they add up 5, 10, 16. Yep, good memory. So it's symmetrical, in other words, right now. All right. Find the, you know what, we're just going to find everything. Why not? Let's find the expected value, and let's find the variance of x at the same time, and let's find standard deviation. I'll just teach you all of it. Expected value of x. The formula was x, the sum of x's multiplied by your probabilities. So it's just 0 times, so E of x equals 0, which also is mu, right? They're the same letter, you got to get used to that. 0 times 1 on 16. 0 times the probability of that occurring, plus 1 times the score times the probability, 4 on 16. What do you reckon, girls? Easy?
I got lost.
You got lost. Cool. So, expected value of x, which is mu as well, right? That's just lettering. Do we accept that? That's obviously new.
Yeah.
Equals. Then it's the sum of the formula. It's the sum of, you know what that means? Sum of. That means add all of your x's multiplied by your probabilities. So x's multiplied by, and then add up to the next one. 1 times, plus 2 times, plus 3 times, plus 4 times.
Okay.
Do you get that?
Yep.
100%?
Yep.
Yeah, it's pretty straightforward as well, right? If you forget it, like bang bang, just multiply and add them up. Nothing too complicated. It's easier to see it the way I'm saying it than it is to think of it in terms of the formula. Equals, I'm guessing the answer is 2. If you want to double check that, you guys, quickly plug it into your calculator. I'll wait for you. You obviously want to write that down as well as an example, so I might wait for you guys to do that.
Yeah, equals 2.
Is Rad here yet? Brad, are you here?
Yeah, I'm here, bro.
Oh, good.
Oh, good.
Good
Yeah, I
stuff.
came a bit late from school, man.
All good, all good. Is this good revision since from Saturday?
Yeah, it's all right.
What do you mean it's all right?
Yeah,
You forgot already?
somewhat.
Interesting, isn't it? Look, it's only been what, 4 days, 5 days, and
Yeah.
and that's what I'm worried about with your prelims, you guys. You got it. Anyways, we'll talk about that at the end. All good. Brad, what about you right now? Does this make sense? What I've just said?
Yeah, that makes sense. Yeah.
0 times. Okay. Eden, what do you reckon?
Yeah, it makes sense now.
Okay. Tiana, all good as well.
Yeah.
Beautiful. So that's it. That's the answer to this one. But I'm going to teach the other two as well. Variance of x. Okay. The formula for the variance of x, there's a few. The one I like to use is this. Okay, just look at it for a second. Variance of x is equal to the expected value of x squared minus mu squared. Okay, what part of this do we already know? What part of this do we already know?
EX. Oh, wait, never mind.
The mu.
Never mind.
You mean EX? Is that what you mean by EX?
Yeah,
This bit.
I'm referring to that as EX. I don't know what's
Yeah,
called. Yeah.
EX. Mu. MU. M.
Okay.
U. Mu. Sounds funny, but that's how you say it. All right. So yeah, this one. We already have that. Good. So that one's tick. That one shouldn't be a problem. Right? You're just going to pretty much put that into this bit. The bit you don't have is obviously this component, EX squared. But that's not too bad. If we know, now watch this, if we know EX is this is my formula for EX squared. EX squared is the sum of x squared multiplied by the probability. Who wants to give it a shot? Just from what I've written here. Who wants to give this a shot? Here's the table. I'm just saying it's the sum of your x squared multiplied by the probability. Who cares if it's wrong? X squared multiplied by the probability. Sum of.
Would it be
Go ahead.
0 squared times 1 on 16?
Plus.
1 squared, 4 on 16?
Yeah, all right, you get it. That's it. It's simple stuff. That's why I've chosen this formula for you guys. There's a few, like I said, but I think this one's the easiest one, because then all you really have to memorize is the basics, and then when you're trying to do the squared, well, you're just going to square the x's.
Can't you just square 2, Sam?
Can't you just square 2? Ooh, no.
Aren't you repeating that? Okay,
No,
never
no, no.
mind.
No, that's okay. It's a good question. Don't say that. Look, it's like you saying this. Imagine this as a plus b for a second, right? So imagine this was a plus b. What we're doing is now a squared plus b squared. True?
Oh, yeah, big mistake
When
there.
you say do the whole thing squared, you're trying to say this, which actually is not the same.
Okay.
No, it's a good question. Don't say never mind. Because that means, you know what, you might have made that mistake, let's say. And then at least now you'll know, oh yeah, of course, that makes sense. I'm not going to make that mistake. All good. We're here. Done. You plug all that into your calculator. And then at the end, you're just going to subtract a simple 2 squared. What do we reckon? I mean, we're going to do 1,000 more, but like, sigma squared equals whatever this becomes. Does someone want to work it out for us? And then we'll get, eventually we'll get standard deviation as well. Is someone working it out? Okay, 1, let me see, 1, I'll work it out, 1 plus 9 times 4, 36 and 16, plus 4, 24 and 16, plus 4 on 16, and minus 2 squared. And your variance is 1. Which means your standard deviation in this case is also 1, because the square root of 1 is 1. All right, copy down what you need. Let me know when you're ready. We're going to go on to the next one. All good?
Yeah.
Yep. All right, I'll move on. 20 friends go out to dinner at a Vietnamese restaurant. 1 has 560 cash, 4 have 350 cash, 2 have 180 cash, 3 have 80 cash, 4 have 50 cash, 1 has 40 cash, 5 has no cash, and are expected to borrow from the others. An armed robber bursts in and sees one of the friends at random. She threatens him, grabs all his cash, and runs away. Construct a probability distribution table and find her expected gain, which means expected value. Right, when you see the word expected, you think of E of x. So again, our table looks something like this. This is x. This is the probability that it occurs. What do we have? We've got $560. We've got $350. I should usually be increasing, but it doesn't really matter. 350. I've got 180. I've got 80. 50. And 40. And $0. I could get 560 from 1 out of 20 people. I could get 350 from 4 out of 20 people. I could get 180 from 2 out of 20 people. I've got 80 or 3 out of 50, 4 out of 20, $40. Wait, what was I? $40, 1 out of 20, and this one should be 5 out of 20. If we've done it right, everything should add up to 25, 6, 10, 15, 20. Good. All right. That's your probability distribution table. Any questions?
Yeah, what was the question? So, like, I don't know.
Annoying.
Yeah.
Yeah, well, I don't know what to say. Why was the question so annoying? Maybe because that usually confuses students and then they can't get this out. But I guess we try to show you guys these so you remember, like, look, even if the question is annoying, if you know what you're looking for and how to find these, just do what you would think to do naturally. You know, you could get $0 5 out of 20 times. You can get $40 1 out of 20, 50, 4 out of 20 times, and so on. It's pretty, I don't know. I agree with you, but I think we always do it only because we know you guys are going to be, I guess, annoyed at it, and therefore you just switch off and usually get it wrong. So don't be one of those students, I guess. That's a lesson learned. All right, expected value. Who wants to give it a shot? Tiana, you want to give expected value a shot for this one? What would it be?
So would you do 560 times 120.
1 on 20, yep, correct.
120.
And plus
Plus 350 times 4 on 20. Plus 180 times 2 on 20.
done. Thank you. Perfect. And you're just going to keep doing that
Yeah.
until you literally get to the end. I'm not going to do the 0 because I think you guys should know 0 times anything is 0. I'm just going to write plus 0. All right. Plug all that into your calculator, and apparently the criminal gain is $140. So the idea is if I decided to go and rob one out of these 20 people, I am expected to make $140. And then I guess what I've got to do is think about, is that worth it, like me doing this, is it worth $140? That's how this works. That's what I mean, but it's not exactly like your mean. This is your mean, right? Expected value is your mean. It's not really your average. So it's a bit of a different definition. But anyways, your mean works really well if you ever get into like the stock market. You need to know how means work because they got weights and stuff. So you've got to really know mean and expected values for this. But anyways, and like in casinos, in fact, if you want to think of another game, casino, all the games there have negative expected value. So they're all calculated to have negative return. So the fact that you're going to play, even if you think you're going to win, by the time you play, this value here is actually negative. So you're never going to win. Even if you win, you don't win. It's weird. You got to understand expected value, but yeah, just so you know, casinos are pretty smart. Obviously, it's all done they're all being calculated to make sure there's negative return, or negative gain, if you want to think of it like that. All right, all good. All right, a regular six-sided die is thrown. Graph the distribution. We did that up there. You know, that was that one. And then find its expected value. Well, to find its expected value, first I think it's good to know the distribution table. There's your X. There's your P. 1, 2, 3, 4, 5, 6, and then the probability. And I think it's fair to say we know that the expected value by now is 1 times 1 on 6 plus 2 times 1 on 6 plus 3 times 1 on 6 plus 4 times 1 on 6. And the answer to that should be 3.5. Let's do variance. My variance is the x squared minus mu squared. Ex squared, so that means 1 squared times 1 on 6 plus 2 squared times 1 on 6 plus 3 squared times 1 on 6 plus minus 3.5 squared. And I'm sure the variance should give you 1. Should. Let's check. Unless I've lost it in my head what variance means. 5 squared in this context, 1 on 6 plus 4 squared times 1 on 6 plus 3 squared times 1 on 6, 2 squared times 1 on 6 plus 1 squared, which is just 1 on 6, minus 3.5 squared. No, there it is, fair enough. Are you sure? Can someone double check it? Gives me 2.91. 35 on 12. I really thought the variance, throw dice. How far you've deviated away. Oh no, that makes sense actually. 3.5 to 6 and to 1. Yeah, that makes sense. But no, there should only be 1. Let's make sure. Again, 36. Oh, I've been doing over 16. Ugh. 1 over 6 plus 4 over 6 plus 9 over 6 plus 3 squared, 4 squared, 5 squared, 6 squared, minus 3.5 squared. Now it gives me negative 3. Oh my god. Right, let's start again. Has anyone worked it out? Alright, I'm going to do it one more time. 1 out of 6 plus 2 squared over 6 plus 3 squared over 6 plus just one of those days, 4 squared over 6 plus 5 squared over 6 plus 6 squared over 6 minus 3.5 squared. Alright, that's it. Whatever answer that gives you. Yeah, it was 2.9. Alright, 35 on 12. Don't round. 35 over 12. I really thought it would be 1. Failed that. Standard, so that's variance. Your standard deviation, which is just sigma, that equals to the square root of this. .707, whatever. 1.707, blah, 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 blah. Okay, any questions? All right. The discrete random variable has the following probability distribution. 0 occurs a quarter time, 1 occurs 9 out of 20. All right, let mu be the mean of x. Find the probability that x is less than mu. Okay, what's the first thing you have to find? Step 1. Find what?
Mu.
Mu. Step 2, then find where the probability of that is less than that mu. So you first have to find mu. So I'll let you guys quickly just try it on your calculator. Can someone tell me the answer for mu? I'll wait just to make sure you guys are comfortable with that. Give us an answer. Anyone got it out?
I got 17 over 10.
17 over 10. All right, perfect. So 1.7. So we want to find the probability. We'll know if it's right in a second. Well, we want to find the probability where x is going to be less than 1.7, which means that's the same as the probability of x being equal to what and what? If it's less than 1.7, agree?
Yeah.
And then that should just be what? 9 over 20 plus a quarter, 36, 56 over 80 is, yeah, 7 over 10. Done. What do you reckon? All good?
How did you get x equals 1 and x equals 0?
Oh, it's got to be less than 1.7. Which number's here? Where is x less than 1.7?
1 and
You want to
2.
find the
Okay.
probability. So the way we're reading this, Eden, is find the probability such that your random variable, your x, must be less than 1.7. So 1.7 somewhere here. It's going to be less than that. Well, that means it's going to be at 1 and at 0. Well, that's the probability of it being 0 or 1. Do you agree with that?
Yep.
Now, if obviously you said greater than, it would have been 2, 3, and 6. Okay. Anybody else have any questions? Mm-hmm. Mm-hmm. Is that it? Let's do this one. Consider the following discrete probability distribution for random variable x. All right, it's saying that 1p, 2p? What the? Okay. And it says now the mean, so we've got to find mu. But how do I find that if I don't have these? Does anyone know? A condition?
Sub in any
Three.
value.
Say that again. You said sub?
Sub in any value. Doesn't
Sub
matter.
in any value. No, that won't work. What was the conditions, Lysandra? There was 2 conditions.
They have to be
Oh,
between
that's
1 and
Yeah, that's fine. But then what's the second one?
it has to be equal to 1.
So then don't you feel like that already you can find P from that?
Yeah.
There. 5, 9, 10, 15. 15P is equal to 1. So what does that mean about P?
1/15.
1.
See? And there it is, 1/15, 2/15, 3/15, 4/15, 5/15. Now you found your P. To find your expectation, that's very easy. 1 on 15 plus 2 times 2 on 15 plus 3 times 3 on 15. I think you guys get the idea. After that, the answer should be D. All good?
Yeah.
So just keep that in mind. You're missing, don't forget your 2 conditions. On any given day, we'll come back to that. It's easy. Find the mean. What is probably that Daniel received only 1 telephone call on each of the 3 consecutive days? We'll do it. Just 1, 0.2, 0.2, 0.2. We'll come to it. That's easy. Just want to see what else. Okay, yeah, let's do that one. The probability distribution of a discrete random variable is given by this. Show that P is equal to this or this. What are you going to do? You just straight away just go show. What are you guys going to do? What are you going to say? Read. Tell me.
Left-hand side equals right-hand side.
But you don't have a left-hand side or right-hand side yet. You're trying to find P, in other words.
Okay.
And again, look at where P is. And then maybe it might come to you, Tiana. Yeah? Go ahead, Eden.
You can add 0.2, 0.6 p squared, 0.1 to equal 1. And
That makes sense. Again, you're just going to sum all the probabilities of the bottom. It's going to equal to 1. That's the only condition you know. And there you go. You will find P, obviously, from this. Because it's got 2 answers, what kind of function must this one be? Quadratic. 0.2 plus 0.1 plus 1 plus 0.1 minus 1. So plug that into your calculator. Let's see, 0.2 plus 0.1 plus 1 plus 0.1 minus 1, 2/5, 0.4 equals 0. Go and jump and straight into your quadratic formula. P equals minus B plus minus square root B squared minus 4 times A times C all over 2 times A. Fingers crossed you get 2/3 and 1. So let's see, 1 takeaway. No, something's wrong. b squared minus 4 times a times c. Oh, maybe not. 4 times 0.6 times 0.4. No, it worked out fine. Root answer is 1 on 5. So you get 1 plus minus 1 on 5 on 2 times 0.6, which is 1.2. Then 1 plus 0.5, no, 1 plus 0.2 divided by 1.2 is 1. And the other one, I'm just going to cheat, is 2/3. All right. Tiana, make sense?
Yeah, it does.
Add the bottom equal to 1, and then just solve for p, really. Realize that it's a quadratic because it's p squared and there's a p. It's quadratic, and then finish it off. All right, you guys. Then it says actually assume p is 2/3, and then go ahead and calculate this and find this. So please go and try that. The answers are here. I'll give you some time. I'll just fix this up so you guys don't get this wrong. So if p is 2/3, that means this number and this number are these. 2 and 3. Squared. 4 on 15. This one is 4 on 15, and this one is 1 minus 2/3, which is obviously a third. All right, go and find the expected value and the probability. I'll give you guys a few minutes to try that.
Is it 28 over 15?
Absolutely, great work. And then you're trying to find the probability where x, now what's 28 over 15? 1.86.
1.86 recurring.
Yeah. And then obviously that means you're trying to find the probability where x is bigger than 1.86, so that's here, and here.
Okay.
And then hopefully if you add up your probabilities, you get 8 over 15. Just confirm that, Tiana, and then we'll move on.
Yeah, I got 8 over 15.
Yeah. So see how this is more algebraic, this topic, and I find a lot of students find this a lot easier than what we might have done last week, which is just basic probability, but the questions are 10 times harder. So I don't know. I find this pretty okay. I hope you guys are finding that too. Anyone having problems with either I or double I?
Nope.
Okay. Not in the syllabus. We don't need to worry about it right now. Extension students should look into it, but not for you guys. That's just a fun exercise for you to do. Measures of spread, we just did it, so we could jump straight into it. See, there's a few of them. There's this. I'm not gonna use that one. I use this particular one. Don't need to worry about the proof. All right, there it is. The random variable x has the following probability distribution where p must be between 0 and 1/3. That's fine. The variance of x is, and you can see all the answers are in terms of p's. So it's not asking you to go and solve this in terms of p. Like you don't need to go and do p plus 2p plus this. Oh, and if you did, just so you guys can see, you're actually not going to get very far because 3p minus 3p disappears, and you're gonna prove 1 equals to 1. Good job. That doesn't do anything. So, but you can see the answers. They're all in terms of P. So follow the formula. The formula was, variance of x equals expected value of x squared minus mu squared. You don't have mu squared or you don't have mu, so first you have to find mu. All right. Let's try this. So mu is negative 1 times p. So negative p plus 0 times this is gone. 1 times 1 minus 3p. That gets me 1 minus 4p. Ex squared. Ex squared is negative 1 squared, which is 1. 1 times p is p. 0 squared doesn't do nothing. 1 squared again doesn't do nothing. 1 minus 3p. Minus 1 minus 4p. 1 minus 4p squared. So that becomes 1 times p. So that becomes negative 2p plus 1. Can I see any answers? Probably not. Let's just expand. 1 minus 8p plus 16p squared. Expand again. Minus 2 plus 8 is positive 6. Okay, any answers yet? Oh, right there. D. What do we reckon, Rad? Easy? Lysandra, all good as well?
Yes, sir.
All right, all good. All good. Standard deviation, like I said, it's just the square root of variance. So you can't find standard deviation, you find variance and then you square root it. And you can't find variance unless you find mean. So I think you guys are seeing it's a three-way step. By this, that's your function. All right, I'll leave that one with you. Let's try that. So create your table. There's your function that you got to create your probability through. You've got x values is 1, 2, 3, 4. 1, 2, 3, 4. There's your x. That's what you sub it into. So k is equal to, x is equal to 1, so that becomes k, 2k, 3k, and obviously 4k. That's your function. And it says find k, which I think we know how to do. Add these up equal to 1. Find the expected value. All right, go and find everything. Find k, find the expected value, find the standard deviation. See if it all works out for you. How are we going?
I'm up to standard deviation.
Nice.
I got 3 for the expected
Expected
value.
value. Perfect. That's
And then
correct.
for the standard deviation, I
Yep.
think I messed up. I'm going to try it again right now.
Yes. All right. So 2 over 10, 3 over 10, 4 over 10, and then you're just going to obviously do 1 squared times 1 over 10, 2 squared times 2 over 10.
I got 7 for that.
And then did you take away 3 squared?
I got 10, and then I took away. Oh, sorry, 3
3
squared.
squared.
Okay, it's 1 then.
Yeah, 10 take away 9 equals 1. You got it.
I didn't square the 3. That was my issue.
Yeah. So
Okay.
new squared. That's variance though. Be careful. Now, obviously, in this case, because it's 1, standard deviation is still 1.
Okay.
But you got to be careful. Obviously, if it's variance, and then you got to square root it. Cool. All right. Anybody else? Well, we're happy. You got yourself. These are usually, from what I'm seeing with the prelim papers, they're usually worth about 5 to 6 marks in total. So it's good. Easy marks. All right, I'm done. Finished. I won't save that one. I'll just send you guys the one with the solutions already. You can stop